Welcome to Vocabulary Video 4.2. This video is about chemical reactions. A chemical reaction is a process that leads to the transformation of one set of chemical substances to another. Example, cake batter turning into a cake while baking in the oven. Another example is a clear substance being mixed with a powder, creating a green substance. We talked about these in the beginning of the year. They're the same as a chemical change. Reactants. Reactants are a part of a chemical reaction. They are the substances that are present at the beginning of a chemical reaction. These substances are turned into products in a chemical reaction. Example, the reactants in the reaction below are ammonia and hydrochloric acid. So as you can see in the picture, the reactants occur on the left side of the reaction. They're what we start with in the very beginning of the reaction. Products. Products are the substances that are present at the end of the chemical reaction. These substances are created by the reaction. Example, the product below is ammonium chloride. So the product is on this side. There can be one product or there can be more than one product, but it always occurs at the end. So the reactants turn into the products through the chemical reaction. So this arrow right here represents the chemical reaction. Synthesis is a type of chemical reaction. In a synthesis reaction, two or more chemical species combine to form one product. Example is A plus B yields AB. So we have two reactants combining together to make one product. Here's another picture of actual compounds and elements, and we have calcium combining together with oxygen to create calcium oxide. Decomposition. Decomposition is a chemical reaction as well. It's a type of chemical reaction, and it is the breakdown of a chemical compound into elements or simpler compounds. Decomposition is the opposite of synthesis. So instead of two things combining together, we have one thing breaking apart into different pieces. So in this example, we have carbonic acid, which is this big compound right here, breaking into simple water and carbon dioxide that we're familiar with. A single replacement reaction, also known as single displacement, is a chemical reaction where one reactant switches places with another reactant. In this example, we have a compound AB plus C yielding or leading to a compound of AC plus B. So we can notice that the B and the C completely switch places here. That's a single replacement reaction. This is kind of a funny cartoon down here. We have one single guy, and then a couple over here. And then in a single displacement or a single replacement reaction, the guy that was single is now with the woman, and the other guy is single. A double replacement reaction is very similar to a single replacement, except for we're talking about two reactants. This is a chemical reaction where two reactants switch place with each other. So now we have my B and my C swapping places completely to gain a new partner. Here's a cartoon that's really similar to the one that we just saw, except for now we have 4 people and they completely switch partners. So now we don't have anybody alone. That's a double replacement reaction when two reactants completely switch places to gain a new partner. Lastly, we're going to talk about combustion reactions. These are the ones that people get a little bit worried about because they look really complicated, but it's actually really easy to tell what a combustion reaction is. A combustion reaction is a reaction where the burning of a hydrocarbon, which is just hydrogen smushed together with carbon, and oxygen produces carbon dioxide and water. We can see an example in this picture down here. So this picture shows the hydrocarbon below, which is CH4, combines together with oxygen, which is O2. That creates CO2 and water, which we are familiar with. So this is a combustion reaction. You'll notice, and we'll talk about in class, that there are 3 elements involved, and that's carbon, hydrogen, and oxygen. The last thing we're going to talk about today is the conservation of mass. This conservation of mass states that mass cannot be created or destroyed. We talked about something similar in the beginning of the year with energy. This means that the total mass in the universe must remain constant or stay the same. Example, in every chemical reaction there must be the same mass of reactants as products. So if you see in this picture we have two reactants, which is in the beginning of the reaction, and they weigh 300.23 grams. Then we're going to shake up the container and we're going to actually react it. And over here, the products of the reaction, what comes out at the end, weigh the exact same, which is 300.23 grams. This shows the conservation of mass. There is nothing lost.